Hello and welcome. My name is Scott Dillery, and I would like to present a methodology for preliminary screening of sites for removing barriers to aquatic migration and adding recreational opportunities. Dams present a barrier between fish feeding areas and reproductive habitats and generally block migration. This can lead to a lack of diversity and even species extinction. So traditionally we've had fish ladders where they jump as they move up. But recent studies indicate the traditional fish ladder does not work well for all species and thus limits diversity. A few facilities have moved to more natural mechanisms that have shown much higher efficiency. So this is a natural, but man-made, natural-looking fish ladder or fish path in Finland. Creating the whitewater canals gives the fish a more natural flow and introduces new recreational opportunities. I'm particularly interested in the boating opportunities, but there's also fishing that this would create, and of course the habitat for watching other species. Kentucky is where I live, and Kentucky lakes are nearly 100% made from dam installation. So this is a good place to start when examining solutions. Now, unfortunately, creating the canals requires a great deal of digging. Whether this is a big project like this one over here, or a small project, or a smaller project like the one over here, it definitely will require a bit of heavy machinery. Now, so the U.S. Army Corps of Engineers has 8 Kentucky dams and reservoirs in its Louisville district. We can use digital elevation data and lake feature data from the state, along with tabular information from the Army Corps of Engineers, to make cursory judgments comparing candidates for canal sites. Using the digital elevation model and the lake information, we can visually pick candidates for where a canal would enter the flow. So here are 2 such candidates, and what we notice about those is these candidates are within the natural drainage of the area and at the height of the winter level of the lake. I chose winter level as that would be the lowest typical level of the lake. Creating a cost function that reflects the accumulated digging required to reach the lake allows us to compare that relative cost of digging for the different candidates at different lakes. And so this candidate, we see cheap cost here, but to actually make it over to here, we get into the yellow area in order to dig that. Now, it will most likely come through the green and into the site here. In this case, now to get to this yellow actually probably requires coming around the yellow this way and then coming back in. So actually going straight across I can see would require more accumulated digging than this site up here. And so with a very quick look, we can get an idea of a general cost of digging those canals to match the lake. This should narrow the candidates to a manageable number for further analysis